Hi everyone, so welcome to another tiny experiment. Something a little bit different this week, although I am sort of re-going back over some old concepts. And how this came about is usually when I'm doing coding in the week, I allocate 3 days where I'm predominantly biasing what I do during the day towards coding, exercises, playing around with code. So the first day I'm usually exploring concepts, just generally playing around with some ideas. Second day I try to bring everything together with the view to actually record a tiny experiments video. And then on the third day I'd sort of deconstruct everything and start going through and laying everything out almost in a linear fashion and seeing if there's stuff that I really need to just explore further. So this actually came about as a result of the third day, which is laying everything out, and I thought I'd share it in a video. And so this is this week's tiny experiments video. You'll notice if you go through this, there's no discrete 10 tiny experiments like there are in a lot of the videos. The idea is for you to, if you want to play around with this, just to do as many tiny experiments as you like. I'm going to show you a few tweaks and tweezes here, and I'm going to explain the code. When I upload this, there'll be two versions. There'll be a slightly stripped down version, which might be better suited to sort of, hacking around a bit. And there's a documented version which might be better suited to understand what's going on here. This is run linearly. We've got very little abstraction going on, so I'm not creating functions for this. This is real sort of old school procedural coding in Python. Not something you'd necessarily want to use in production, but it's a great way basically the way I try and get my ideas to consolidated and understand what's going on under the abstraction, because I find it's really easy to forget what I've often done or what I'm playing around with in certain functions. So it's quite nice to just lay it out as a continual stream of thought, even though you wouldn't want to do it like this in production code. But it's great for R&D, great for tiny experiments. So let's walk through this. I do have a couple of abstractions I've lent into. I didn't want to write some request code from the ground up without using a library, so I have lent into the request library. And there is one instance here where I need to grab something from my environment, so I do have the OS library here as well. But that's the two instances. The request is used for when I actually finally get around to issuing the request to the API. And the OS is just, like I said, for this bit here. With most experiments, when I'm playing around with Google Gemini and I need an API key, I'll do it by putting it in as an environment variable. There's several ways you can do this. I find for doing demos like this, where you don't want to start giving out your API key, doing it this way is probably the best, but I accept there's other ways to do it, which will obfuscate the key in various ways for demo purposes. This also makes a great way for uploading it, because then the person has to go out and actually get a key themselves, because when I upload this, there's no reference to the actual key itself. It's only a reference to the variable where the key is commonly saved. And this is a common name to give it. I believe originally it may have been called Google API key at some point, and you've probably seen some of my code which checks for both. This code is very stripped down, just checks for one thing. There is no, there's no try stuff in here. So if this breaks, it breaks. There's no failing gracefully for this. It really is like roll your sleeves up. And there's multiple ways you can take this, but to get started, you will need access to Google Gemini, so you need an API key, which you've got through having a Google account. I've spoken about this in the past, but I will include links so that anybody that hasn't got that can go away and do that. You'll need some sort of IDE. I'm using Visual Studio Code. I've also got, but it's not required, I've got a few marketplace extensions installed just to help with the code in terms of, when I'm coding it up. And it obviously also need Python. On this system, what have I got currently running? Python. I think that's how you do it, yeah. 3.13.5. Yeah, you can do all sorts of clever things with different environments, virtual environments, Docker, whatever. As you know, I'm usually breaking Visual Studio Code at some point, so this very recently was uninstalled and reinstalled. Obviously, if I was working in a production environment, I'd be a little more careful than I am. But, I'm playing around a lot, so the way I look at it is if I break something, I can just reload anything. And because everything else I've got is stored off machine, I could basically rebuild this machine and it wouldn't cause a problem with any code that I need to keep for any reason. It's just time and effort. So what else have we got here? To keep things simple, I'm not doing anything smart with string concatenation, or what do they call it, string interpolation. So I've actually got two endpoints here which are very similar. I could have got clever and had a base Google Gemini endpoint which would have consisted of this probably, and then interpolated onto it the model, which is hard coded here, which I'm using Gemini 2.5 Flash, and also in this case for the Gemini endpoint itself, this generate content endpoint. But you can do that how you like. Here I'm not too worried about it, so I've got a bit of redundancy in here and I'm not trying to build stuff up as I usually might. So first thing we're going to do is get the model data, which is using this endpoint, and it doesn't need much to do that. You need an API key, which we have, and it needs to be sort of loaded up. You'll see this all sort of spliced together in a moment, but it's pretty straightforward. There's just this parameter key which has a key inside it, this particular bit here, should I say. So we need to push that in here, and that just contains this key value pair, which is the word key and the API key, which we've grabbed already. So we're going to do a request using the request, well, specifically the get method from the request library. So we're going to get our request, which consists of the endpoint and the parameter. That will come back. We will use the JSON method here on our response object to give us model data. And then we're going to do something very quick and dirty. We're just going to iterate through our key value pairs. The model data structure that comes back and is subsequently turned into a dictionary that we can iterate through is pretty straightforward. There's nothing too funky going on. And then very quick and dirty, we're just going to stop the script temporarily so we can review what's on the screen. This is really just for information purposes, so we can actually see the contents of our model data response. So we have the name, the version, the display name, the description, the input token limit, the output token limit, the supported generation methods, of which we will be using one, the temperature, the top P, the top K, the maximum temperature, which is useful to know, and whether thinking is on. And that's what you get back if you do that sort of request. Okay, so moving on. Now the other thing, if I didn't mention it at the start, I've got two versions of this I'm going to upload to my GitHub page, and I'll include the link in the description. So it's actually just the folder where all the tiny experiments are in. And if you check the experiment number for this episode, it'll be in that particular subfolder. But I'm going to do both here. So I'll do the stripped down version and the version with a bit more documentation in it. So you can basically use whatever version you want. So when we get down to this next bit, and again, of course, this in real life, you'd refactor all of this. So, all of your variables or whatever are all put together in a nice, neat place. The other thing is everything is hard coded. This is the only bit of user interaction. It's that way by design because we're purely playing around in like a coding sandpit here and just, making changes, rerunning, that sort of stuff. So this is really sort of preliminary testing before we start to do any clever abstractions or, user interaction stuff. So we have a text we want to go in. So here, because we're not specifically asking for the prompt, we've just hard coded it in. And of course, to modify this, we would just modify this bit here. It's set up to do at the moment with sort of multi-line automatically. So I can, if I want to change this, start typing in extra lines here without too much trouble. Hence the presence of the triple speech marks. So explain the concept of LLM embeddings in simple terms. So that's our prompt, that's our text. You might even want to relabel this variable to make it more descriptive. Then we've got the system instructions here, which is just set to the good old "you are a helpful AI assistant," but this one has a flourishing mindset. Might as well do a full stop there. There's lots of ways you can play around with system instructions. In Google Gemini, there's a specific way of doing it where it has a separate part for system instructions. In some platforms, like a Llama, you might find that the system instructions are mixed in with roles as part of the main contents. So you'll get a role like user or system or assistant, that sort of stuff. But in Google Gemini, it's nice and separate. And you can do some sort of shenanigans with the parts and with the system's instructions, which I'm not going to go into because that's part of the experimentation bit of here. Why I don't have finite experiments in this episode is because the idea is here's the code, you go away and experiment and see what you come up with. We've got a number of generation parameters we're going to set. When we get down to the payload, you'll notice where they plug in. But, of course, you can simplify the payload so it just doesn't set those at all, and then it just uses whatever the defaults are. At the moment, I have it defaulting to the defaults or setting to the defaults just for starting convenience. But obviously, this is the sort of stuff you want to change. But you can see that it's set to whatever the default would be anyway. So if I was to completely remove this section of the payload, it would just use these. So at the moment they're identical. So temperature is set to 1 right in the middle because the max temperature is 2, so the minimum temperature would be 0. It just saves you, if you know the max temperature, setting it to something stupid and actually never going above the max limit. So if I set this to 100, usually it wouldn't crash or do anything, but it's just going to go 100. No, the max temperature is 2. That's what it's going to be. So it's good to know that so you don't start doing unnecessary experiments. Usually in other episodes I will set this to sort of something like 0.7 if I'm doing more factual stuff, and higher if I'm doing more creative responses. But it's a nice middle ground for this, and you can experiment with this and see what sort of responses come back. Top P controls the diversity of the output, and top K limits the sampling. So all of these sort of contribute together to play around with the underlying math that's there, and the probability stuff, and the vector, and everything else that's going on, and the embedding, and So what I will do is I will include a link to the API documentation so you can fully understand what's going on here. You could even actually just feed that in as a text, couldn't you? You could say, can you explain the concept of top P in LLMs or something like that? So you can get very meta with this and actually use this experiment to actually answer your own questions about the experiment. We've got a thinking budget of -1. So this looks a bit odd if you haven't worked with thinking budgets before, but by default you can see thinking is on. But you can then choose to switch that off or set a particular budget. And -1 is saying, yeah, knock yourself out. Use as much as you want based on what sort of question I'm asking. There is a maximum for this, and you have to check the documentation. I can't remember off the top of my head because it's different for different models, as is several of these. Like, top K, in some models I've seen the default be 32 or 48. For this model it's 64, and that is all over the shop also if you get into the worlds of using stuff that's on Hugging Face or stuff that's on Llama, that sort of stuff. But for the thinking process one, -1 is this dynamic thinking, whatever you want to call it. 0 turns the thinking off. And then you can put a value in, which often is multiples of powers of 2, or powers of 2. So like, I don't know, 512 or whatever you fancy. But the documentation will tell you the range of values you can use and what maybe, moving them slightly, what factor you've got to increase them by to actually make a discernible difference, if you know what I mean. Okay, including thoughts. Now, I was playing around a little bit with this earlier, so I'm actually going to set these in the code I release to false for the moment. So even though thinking's going on, by default it won't include thoughts in the response, even though there's thinking going on. So whatever you set to this to, by default, including thoughts is not including thoughts is not included. Yeah, it doesn't include thoughts. So I'm just setting that the same as it would be by default anyway. But in a moment we're going to be setting that to true. In this, I might as well do it. Yeah, it was supposed to be false. I've been messing around with this a little bit just before recording. Then we get grounding, which is really interesting if you've never played with this. So this is the ability of models, if they have that ability, to go away and do supplemental Google searches. And by default, in this particular model, grounding is off. So I'm going to switch it. So I'm going to leave it to that at the moment, but we'll do a second test in a moment where we'll switch both thoughts and grounding on, and then we'll leave grounding on and switch, we'll leave include thoughts on. So all of these I am going to have this as the thinking budget, which means just, do what you will. But for a couple of experiments I'm going to do here, without spoiling too many experiments you might want to do, I'm going to just play around with these values here to see whether the thoughts are actually included in the response, and to whether there's grounding going on. And you can sort of see how that might affect what's going on under the bonnet. Then we get to build this. So our header's a bit more complicated this time round. Before we were using this sort of parameter type thing for just getting the model details. Here we've got like a full-blown header that we're going to use, which has got our API key, but also this content type. With certain requests, you don't always have to include this. I've got it here just because it's interesting in terms of what content might come back. But the default, this is the default anyway, so yeah, we don't need to worry too much about that. But I've got it there anyway. Then we get the actual payload itself. So we've got our system instruction section, and so this is laid out a little bit so you can read it, maybe understand how everything's clustered together in this request we're sending. Excuse me. So we have our contents, which has parts, and in that parts we have some text, and the text is indeed the prompt there. There's our system instruction, which we set earlier. And these are our configuration, generation configs. There's our temperature, there's our top P, there's our top K. The thinking config is composed of a couple of things. The thinking budget, which affects whether it thinks or not and how much it thinks. So switching it off, as I've said before, you set the thinking budget to 0. -1 is do what you will with the thinking, and then a value restricts the amount of thinking it can do. And then including thoughts doesn't affect the thinking budget directly, so having this on or off doesn't stop the model thinking, but what it does do is in some ways speed the response up a little bit, I suppose, in that it doesn't come back as part of the text section of the response, which we'll see in a moment where that is. And then this bit, which is the tools section, which you add on this whole section to just instigate this Google search. Now, if you look at the API documentation, you might well find, well, you will indeed find, that there's more that I'm explaining here in terms of what these sections can contain. But this is a good starting point. You can get into some clever stuff with output token limits and all manner of other things as well under generation config. And there's some other clever specific search URL related stuff you can do as well if you really want to. But we won't bother looking at that. One word of warning here. If either you like to use some form of AI augmentation like I tend to use, where I'm sort of bouncing around between hand coding and then, grabbing a bit and seeing whether there's a better way of doing something or a different way of doing something, or reminding me how a certain thing is, and you're feeding this through some form of code generation or code completion, be careful of this section, because a lot of LLMs, the way they're constructed and everything like that, you sometimes get back completion values which don't fit what they should be. So it's quite possible for you actually to feed this back through an LLM and say, okay, can you improve this? Or can you just tell me about it? And it will actually sometimes reformat this to say Google space search. So it'll mess with it and go, oh yeah, well, even though we're dealing with Google Gemini here, I've seen it do it in Google Gemini where I've fed this code in and then I get an error. And when I rerun the code again, it's spat out. Maybe I've asked it to do some documentation or to maybe refactor something that I wasn't happy with. This code that I did here, a lot of it was me just building up from looking at the API documentation, but I did feed it through at various points just to confirm a couple of things that I was unsure of. And sure enough, it reformatted this to say Google space search. So yeah, just watch out for stuff like that. And then we've got a bit at the bottom here which conditionally enables or disables the grounding. So it takes this section here and either takes it out or puts it back in based on what's in there already and what you want in terms of the value you set earlier. Okay, so at the moment it's a little bit overkill, but if you were to put this in a loop, then there would be reasons why you would want to switch this off and on and to establish the state of it before you did it. At the moment we know that it's always going to have this in it because that's the way it's set, and it's actually removing it in some instances, so it's a little bit wasteful. But if you were to then take this and refactor the code and maybe put this section in a loop separate from this and have it so you could easily switch between the two without basically running the code, then the need to do some of these extra steps which seem redundant in the way this is set out linearly would become more useful. This here is the same as this. I've just condensed it down here. So you can see the nice thing with this is we can sort of manipulate this like we can manipulate a dictionary or a list, referencing the particular parts here, these sort of key and then assigning values or other key value pairs or whatever. Okay, so then we get around to sending the response, sending the request and processing the response. So send the request. Here's our response. We're doing a post here. So we have our endpoint, which is the Gemini API endpoint. Again, I could have done some clever interpolation shenanigans and text string concatenation, string interpolation stuff, but I just chose not to. We've got our headers. We've got our request payload, which is all of this stuff, plus any tweaks we've done. And then we get our generated parts. So we're pulling out just the bit we're interested in from the response data, which we've fed the response through and applied this method to it, which is part of the response library, and that allows us to extract parts and play with it as though it's a dictionary. So we have a part or parts, which are our generated parts, which is actually going to be in itself a part which could potentially be a list of text stuff. So we have a piece that will handle that, and that will vary based on whether you've got the thinking, including the thoughts, on or off. So as I've said before, with this set to -1, thoughts are going to happen whatever this is set to, but whether you include it, that's what that controls, this true false thing, this Boolean value. So what I'm doing here is just taking that generated part and going, it's iterating through the parts. So if there's only one part there because we haven't asked it to return whatever thoughts it was thinking, then there would just be one part. If there's two, because there's the thoughts it was thinking that we are now revealed to us, and actually the response, then it would be two passes through this. There'd be two parts, two iterations. We also want to grab the grounding metadata if it's there, and that's the stuff that's related to our search grounding. So, and you can see here some commonalities here. So it's all inside of this candidate stuff in a certain part. And here we're pulling out this grounding metadata part, and then further just checking to see. So here we are actually bothering to check to see if any of that's present, because we're going to be switching stuff on and on, off and on. So we've got the web search queries part, which is just a list really of the queries that were done by the model. And then this bit, which is the grounding chunks, which we're only taking out just the URL bit. There is a title component which we could use as well, but we're not going to, which we could print out. We're just printing out under web, under the web key, there is another key value pair of URI and then the URI and then title and the title. But we're just pulling the URI from there. But in both cases, we are just checking to see, is it even worth checking if that, based on whether or not the metadata has the grounding in there. And obviously it's going to appear and disappear based on whether the grounding's on or off. So that's why it's useful to check for that. And then finally, we just print off a summary of any values we've set, we've hard coded. So we know at the end what we've got. So we ran this, and you remember the first bit where it just comes up and tells you, okay, we're using Gemini 2.5, which is hard coded in, but we're just doing a check of the model anyway. So yep, it is actually using 2.5, surprise, surprise. Version 1, the display name, the description, the input token limit, the output, the generation methods available, the temperature, the top P, the top K, and the maximum temperature, and whether the thinking's true. You can play around with those. You can play around with more than this. you can go down and you can obviously, if you play around with more, then maybe you would want to print that out later. But this bit here is printed from me iterating through the key value pairs that come back when we do the model endpoint request. Okay, so this is the only bit of user interaction. So it's preparing the request, sending the request, boom, there we go. So there's our response. You can see here, yeah, it's basically .md format. So we could do some stuff where we just save this to MD. For this particular experiment, unlike other experiments that I've done, I'm not saving any of this data anywhere, but that's something you could obviously experiment with, is saving data. Why are they useful? We've got no, there's actually no Google grounding information included here. You can see that Google grounding info on there. Now, what's interesting here is I did inadvertently, this was from earlier, I didn't think about that because I made some changes here. So let's rerun this actually, because here you can see it's true. That's why this has appeared. So this is interesting. It's attempted grounding, but it didn't look like it did anything. So what I'm going to do is rerun this. Oops. So thinking's true. Okay, we'll rerun this. So this time round, if you remember in here, we did, where's it gone? We did switch off, yeah, including the thoughts and enable grounding, but thinking itself is on. Okay, so all set to false. There we go, that's better. So as expected. So there's our response data. Okay. And there's our summary of our request parameters. So let's try switching on the, let's do this in stages rather than doing it in one. Let's include the thoughts. So the thoughts are on. And we will run this. Just to be on the safe side, let's save it. Shouldn't make any difference if I do it this way. Where it makes a difference, if you do an up arrow and then try and rerun it from here, then it will just use whatever's currently in memory. So we will do that just. So yeah, this is just restating what we already know. It's not restating anything after the changes, so it doesn't really matter. It's that information is not going to change on each run. Okay, just reminds us of what the default model looks like before we mess with it. Okay, so we've set including thoughts to true, and what you'll notice is, here we go. So you get this. So now it's iterating through, and instead of it just finding one part, it's finding two. So this is the first part, explaining my thought process. Then there's the divider here, which is hard-coded in, and you could, make that a little bit clearer if you wanted to in your experiment. And then there's the actual response itself, and then the request parameters. Now notice grounding is still off, so we haven't got any search grounding. So let's switch that on. So we've got grounding on, and sorry, we've got grounding off in a moment. We've got include thoughts to true, so it will include those, and then we'll switch enable grounding to true. And we'll see if there's any difference, whether it affects, because we can see the thoughts. And even if we had the thoughts to true or false, the underlying thinking would still go on, but we're actually going to see what it's thinking. So we're going to see whether there's any difference between what it thought with the grounding off and what it thinks with the grounding on. And that's probably as much as I'm going to do with my experiments, because I'm handing it over to you now, the viewer, to your own experience. So I don't want to spoil anything here, but you probably guess the next thing I probably try is mess with the thinking budget. And then, you know, compare and contrast, like having no thinking with grounding on and thinking with grounding off and so on. So, yeah. And then play around with some thinking budget thresholds. You could add a timer in this as well. You could get really clever with the time date library and start looking at seeing how long it takes. So you can see now this is what this looks like. So we've got it did 3 queries that it did, and these are the source links which you can click on and be taken to. Notice I mentioned that we didn't include, we could have pulled the title details for the websites, but we didn't. In other episodes where I look at grounding, there's going to be other episodes I'm going to do in the future where we will be featuring grounding, which is one of the reasons I wanted to do this episode, actually. So you were sort of forewarned. I'll probably have some code in there which actually also returns the, I say some code. I just tweak this so this prints out the web title chunk as well, part of it. So yeah, the web title part of the chunk, and there we go. So yeah, as I've said, embedding. So let's now see, because we know what the thinking was. Now what's really interesting is with grounding on, okay, so this is cool. So I don't know if I've seen this before. So this is one reason why it's useful to loop through the way I've done it, which is loop through the responses, because you can see it looks like we've got 3 bits now. So in the past when I've run this, the limited amount of testing I've been doing, because it is quite unusual when I'm doing stuff to actually get it to, even though the thinking is on, which I have on almost all the time I do these experiments, I very rarely get it to show the thinking. So the data that comes back as part of the parts, the text part, would only be one chunk of text. But once you switch on to actually display what it actually thought, so you can see what it's being, you include the thoughts, then it could come back with like multiple chunks. So you can see here we've got this bit and then this bit, and then we get on to the actual response. But what's interesting is if we look up here, you can see it seems to have done it in a slightly different way. This is all one big chunk of thought process, whereas this is where is it? Oh dear me. Yeah, this is 2. So that's another thing to play around with, is, you know, do the results force it, or do the settings force it to actually do more, I wouldn't say fragmented thinking, but yeah, chunk down the thinking a little bit, is something interesting to explore with. You know, what happens with this when I whack up the temperature? Do I get more or less thinking going on? Yeah, so things to play around with. So let's just change this back to how it was before I upload this code to my GitHub. I'll make everything available on GitHub. I'll have both the documented version and the undocumented version, so you can just use whichever one suits your way of working. And any other interesting links that I think are useful beyond the API documentation as well. But let's just run this one more time while we're at it. And then you can go in. Other things to play around with while we're waiting for this to run is you can... Yep, so that first bit. You might want to just chop that out now as well, because it's pretty much redundant. It's just going to come back the same every time. It's only of use when you start playing around with the different models, if you want to try a different model that you may have got access to. Obviously I'm limited here because the model I'm using or have access to are based on the fact that I'm on the free tier. Okay, so this is back how it was. So thinking is happening, but we just asked it not to include it. And no doubt if I then change this back to true again, we probably get the similar sort of result. We ran it first when we didn't run grounding. What else might change some stuff up? I mean, you know, just play around with everything. You know, how does changing the instructions affect the way it thinks? Is a good one. Does it think more or less? And there was one other one I thought, oh yeah, if I include the API documentation, you'll probably find there's a whole string of things under generation config that are worth just playing around with. I'm not saying they'll be any good in like day-to-day searches, but they're useful for certain specific things where maybe you want to restrict the amount of stuff that comes back for a certain experiment. Those sort of things. Maybe you're just interested in like the first 100 words or 100 tokens. That's quite fun to play around with, to see sort of commonalities in response as you change other things. So there we have it. Hopefully you'll enjoy playing around with this. Thanks once again for watching. Bye for now, and I will catch you in a future episode.